Today we're going to talk about a way to keep track of energies in a system called an LOL diagram. The reason it's called an LOL diagram is because that is the exact shape of the graph. So you have an L, you have an O, and you have an L. We'll start with the O. In the O, you write down what is in the system that you are looking at. So for example, let's say I have a ball and I'm going to drop it and it's going to go moving towards the ground. Okay, so the things that I want to look at, the things I care about, the things in our system is the ball and the ground, or you could call this the earth. Either works. Okay, so we're just writing down what is in our system. What are we looking at? Now we'll move over to the left L. So this is our initial situation. Okay, our initial situation, we're making a bar graph. So we're going to make a bar for every type of energy that we see. So I know that there's going to be gravitational potential energy, so I'll write that as GPE. I bet there's going to be some kinetic energy, so I'll write that as a KE. And then, we'll just start with that. So when I look at this first snapshot, so I'll label this right here, right before I release it, as my first snapshot. This is my initial situation. In this initial situation, I am going to give myself a full bar of gravitational potential energy. But because I have not released it at all, it's not moving yet, I'm going to say I have no kinetic energy. So I'm going to put a little X right at the bottom so I know that, hey, I have thought about the kinetic energy and I say there is none. Okay. Now I'm going to divide this up into 4 sections. So we're going to say that I have 4 chunks of gravitational potential energy, and that is the total amount of energy in my system in this snapshot. Okay. Now let's move over to the right L. This is our final situation, our final snapshot. We'll say that is right here. This is our final, okay? Just before it hits the ground, but when it hasn't quite hit the ground yet, okay? That's what we're going to say our second snapshot is. Now I still think I'm going to bring over my 2 energies from from before. So I'll say GPE for gravitational potential energy from that height. And I'm going to bring over that kinetic energy. Now this time, if I'm thinking about the ball and it's right here, almost touching the ground, I'm going to say there's pretty much none. There's no gravitational energy at all, so I'll put an X there. That means that my ball must be moving, which makes sense, it's falling towards the ground, and that it must have all of the energy in this case, since we're only including 2 types of energy. So I'm going to give myself the same full bar as before, and I'm going to give myself 4 chunks. In every LOL you draw, in every diagram, however many chunks you have on this side, so in this side I have 1, 2, 3, 4. I should end up with 1, 2, 3, 4 on the other side. Let's look at a different situation. Let's say the ball hasn't quite hit the ground yet. So we'll erase this, and we're going to pick a new final situation. Okay? We still know that there's going to be gravitational potential energy and kinetic energy, but instead I'm going to be looking at this situation right here. I'm going to say the ball is still falling through the air. It has not hit the ground. It's not even near the ground yet. It's about halfway there. I know there's going to be both gravitational potential energy because it has a height, and it's going to have a kinetic energy because it's moving. It has a velocity. But now I have to decide, oh, there's both types of energy, but which one has more? That's up to you, okay? We don't have any numbers in this situation. I'm just going to go ahead and say that I'm going to have more kinetic energy than gravitational potential energy. So now I have to be careful. See, I made each of these chunks about the same height, so I need to give myself 1, 2, 3 chunks from about the same height as before, which means there's one chunk left for gravitational potential energy. I started off with 4 chunks of energy. I ended with 1, 2, 3, 4 chunks of energy. Okay? What if I had decided that there was the same amount of gravitational potential energy as kinetic? Easy fix. Just take away one of the chunks and put it over here. So I have 1, 2, 3, 4 still. Okay? This is an LOL diagram. This is how we'll be analyzing energy systems in this class. If you don't understand this, practice makes perfect. We'll be looking at lots of situations. See y'all